Name is Ethel. I am someone of Ethel from Section 9A. We'll be experimenting about how magnets affect the environment. Now, for the objectives of learning, understand and use diagrams to picture the pattern of the magnetic fields of magnets, which I will be explaining about later while I'm doing the experiment. Know and describe the relationship of magnets, compasses, and the Earth's magnetic field. Define angles of inclination and declination in navigation. I'll be explaining that later also. Understand and describe the differences between the geographical poles and magnetic poles. Know the various uses, implementations of magnets in navigation. So the materials are bar magnets with the imprint, the north and south imprints, a 11 centimeter cotton thread to tie it, and a compass. And for the safety measures, lab coats and surgical mask because this is an outdoor activity. So see you later. Okay, so at my carport now, outside, and these are the materials, and this is myself. Hello, I'm Ethel. Doing this experiment, yeah. The very next procedure is lifting this bar magnet, this bar magnet in the middle of the air with your finger. Use your hand. Now, please lift it gently so it won't swing violently like this. No, we want that to be uh, gentle. Just lift it gently, slowly, so it won't fall. Now, the red part is the north, and the blue part is the south. Hence, when you lift it up, you might see one of the north is fixed towards a certain direction. For me, it's in front of me, which is my neighbor's. Look, yeah. And the blue part is going towards me, which is my house, at the direction of my house. Now, to make sure that this isn't a fluke, I want to rotate this 180 degrees from its original position. Wait, let me just, yeah, look, okay, 180, and go, and it fixes, and it turns to its original position. Yeah, it returns to its original position. Let me just gently touch it, yeah. Oh, to make sure this is real, let me turn it 180 again in the opposite direction. Go. It still goes to my neighbors for the north. Therefore, this is real. Because why? Because in fact, the Earth is just a giant magnet. Because as the inner core is made out of molten iron, which is ferromagnetic, and because being ferromagnetic means it attracts magnet. Due to that being so, this magnet always point towards that for the north, and for the south it points to my house. Yeah, it always points there, points to make sure that's the north. Oh, come on. Okay, that's the north. So we are going to use a mini compass, or whatever compass you have there at your disposal. Now, to make sure this is working, rotate left, and rotate right, rotate left. Then. So yes, it is in fact that my neighbors are on my north roughly. That's the north, and the south is pointing to me. This is because that the north geographical pole is on here, and on the north geographical pole you can find the south magnetic pole. Magnetic and geographical is two different terms. You need to focus on that. and the north magnetic pole can be found on the south geographical pole, which is here. So this is the north magnetic pole, the U, and this is the north geographical. This is the south magnetic. Because of that, the north attracts the south, and the south attracts the north. So what I'm going to do here is to prove that these compasses have relation to magnets. They use magnets. So what I'm going to do here is put a magnet now. See there? The north needle of my compass uses the north pole, which attracts the south. Therefore, taking advantage of the south magnetic pole of the Earth, because as I said previously, the Earth is just a giant magnet. The core is magnetic, ferromagnetic, because it is made from molten iron. Yeah, and it also works for the north, which attracts the south. Look at that. Now, in geography, in compasses, we have something called inclination, angle of inclination, and angle of declination. So what we're going to do here is the inclination is made out of the horizontal lines and the point where the north needle is pointing. So if it points upwards, this area and this area, the angle is considered as positive. If it's pointing downwards through the floor, it's minus. So, oh my goodness. So to have this in X trial, we turn somewhere 90 degrees. Now, if you look at that, the inclination is negative because it's going downwards, the north needle. Yeah. And so is for when I turn to my left, it points upwards, so the inclination is positive. For the declination, it's a bit of the opposite. It's only verticals. So it's made out of the vertical line and the north needle as well. If it's pointing to the east, which is the right, the east is always the right, is considered as positive. If the west, it's negative. So once again, let's try this. So the north is pointing to my west, my left, so it is negative. This is because that the south magnetic pole is not directly on the north geographical pole. Do humans notice this? Yes, of course, because in aviation, logistics, open seas, naval, on the Navy, like boats and ships. So when you're traveling somewhere, it is important to know where you are going, either north, south, east or west. When you're riding an airplane, you only see clouds, and you have no visual idea of where you're going. So it is important to have instruments like the compass. If you're a pilot, you must know the instruments, you must know the information around you, the tools, the apparatus that you must use. So therefore, it is important to know where you're going. If you're going east, north, south, or west. It's also important to navals on open seas because you have also no visual idea or hints. And that is all from my experiment. This is Safan, now from Section 9A. Thank you, Ms. Ethel. Goodbye. God bless you. Have a nice day.